November 1943. OKW, Oberkommando der Wehrmacht Headquarters, East Prussia. German intelligence officers hunched over maps of the Western Front, calculating Allied armored strength through methodical daily reconnaissance reports. The numbers came from multiple sources: Luftwaffe reconnaissance flights photographing American ports, Wehrmacht field intelligence documenting tank serial numbers from destroyed vehicles, and captured documents revealing production schedules. The analysis seemed consistent. American tank production appeared to average approximately 150 to 200 medium tanks per month across all manufacturers. At this rate, German planners calculated, the Allies might field perhaps 20 to 25 armored divisions by late 1944, a substantial force, but one that could be contained through defensive strategy and Germany's superior tank designs. The math was logical. The intelligence was accurate in methodology. The conclusion seemed sound. The conclusion was catastrophically wrong. What German intelligence failed to comprehend, what seemed impossible to believe, even when evidence accumulated, was that American industry wasn't operating like German industry. It wasn't producing tanks the way you build complex military equipment through careful craftsmanship in specialized facilities. American industry was building tanks the way Henry Ford built cars: mass production, assembly lines, standardized components, multiple shifts, unlimited resources. By late 1943, Chrysler's Detroit tank arsenal alone was producing 750 Sherman tanks per month from 3 massive assembly lines operating around the clock. The 11 American factories producing Shermans collectively exceeded 2,000 tanks monthly, not the 150 German intelligence estimated. In 1943, American factories completed approximately 21,000 Sherman tanks. That single year's production exceeded total German tank output from 1939 through 1943 combined. When German field commanders reported encountering more Allied tanks than intelligence calculations suggested possible, headquarters dismissed the reports as exaggeration. When reconnaissance flights photographed American ports with hundreds of tanks awaiting shipment, analysts assumed they were seeing the same vehicles repeatedly. The alternative explanation, that America was producing tanks faster than Germany could destroy them, seemed too absurd to credit. But it was true, and that industrial disparity would prove more decisive than any tactical innovation, any superior engineering, any battlefield brilliance German forces could muster. This is the story of how American automobile manufacturers transformed from building civilian cars to producing an average of 45 Sherman tanks daily for 3 consecutive years, an industrial achievement that stunned German military planners and made Allied victory in Europe inevitable through sheer overwhelming materiel superiority.
The fall of France in June 1940 sent shockwaves through American military planning. German panzers had smashed through the French army, considered one of Europe's finest, in 6 weeks. The Blitzkrieg demonstrated that modern warfare demanded armored forces operating with speed, coordination, and overwhelming firepower. The United States Army had almost no modern tanks. In July 1940, the entire U.S. Army possessed fewer than 400 tanks of all types, most of them obsolete light tanks unsuitable for combat against German panzers. The M2 medium tank, America's frontline armored vehicle, mounted a 37mm gun that couldn't penetrate German tank armor at combat ranges. It weighed only 15 tons compared to the Germans' Panzer IV at 25 tons. The gap was terrifying. If America entered the European War, and by mid-1940 that seemed increasingly likely, American forces would face German armor with equipment a generation behind. In July 1940, the War Department authorized development of a new medium tank and formation of the 1st American Armored Divisions. The prototype, designated T6, would become the M4 Sherman, the tank that would carry American forces across Europe and the Pacific. But designing a tank and producing it in quantities that mattered were different challenges entirely. Germany had been building panzers since 1934, with established factories, trained workers, and refined production processes. America needed to create a tank-building industry from nothing and needed to do it faster than seemed possible. The solution came from an unexpected source: K.T. Keller, president of Chrysler Corporation. In mid-1940, government officials approached Chrysler about building tanks. Keller's response became legendary: "Yes, where can I see one?" Chrysler had never built a tank. They built cars. But Keller understood that tanks were fundamentally mechanical devices with engines, transmissions, suspensions, and armor, all things automobile manufacturers knew how to make and assemble. If you could mass-produce cars, you could mass-produce tanks. Keller proposed building an entirely new factory dedicated exclusively to tank production, not converting existing automotive plants, which would disrupt civilian vehicle production, still considered essential. A purpose-built tank arsenal using automobile assembly line techniques adapted to military equipment. The government agreed. Construction of the Detroit tank arsenal began in September 1940 on 113 acres in Warren, Michigan, 18 miles north of Detroit. The facility would be government-owned but Chrysler-operated, a model that would be repeated for other wartime production facilities. The arsenal opened in April 1941, 7 months from groundbreaking to initial production. 8 months before Pearl Harbor, American automobile manufacturers were already ramping up for war production that everyone knew was coming.
The Detroit tank arsenal incorporated innovations that revolutionized military equipment manufacturing. Instead of building tanks like craftsmen assembling custom machinery, Chrysler applied Henry Ford's assembly line philosophy. Break complex tasks into simple, repeatable steps. Use standardized components. Employ unskilled workers trained for specific tasks. Maximize efficiency through continuous workflow. 3 massive assembly lines ran the length of the facility, each over 1,000 feet long. Tanks moved down these lines on specially designed carriers, while workers added components at each station: suspension assemblies, armor plating, turret rings, engines, transmissions, tracks, weapon systems. The process was choreographed like a mechanical ballet. Each station had specific time allocations. Workers repeated identical tasks hundreds of times daily until movements became automatic. Supervisors monitored flow rates, identifying bottlenecks and adjusting workforce distribution. Chrysler recruited workers from Detroit's automotive industry, men and women who understood assembly line production but had never seen a tank. They didn't need to understand overall tank design. They needed to install specific components repeatedly and correctly. The first M3 Lee medium tank rolled off the Detroit Arsenal lines in April 1941. By late 1941, production reached 20 tanks daily. By mid-1942, output had climbed to 30 tanks daily from each of the 3 assembly lines, 90 tanks daily from a single factory. In January 1942, the arsenal converted from M3 Lee production to the new M4 Sherman. The Sherman incorporated improvements over the Lee, notably a fully rotating turret with a 75mm gun compared to the Lee's awkward hull-mounted gun with limited traverse. Sherman production at Detroit Arsenal accelerated through 1942 and peaked in 1943 at 750 tanks per month, 25 tanks daily, every day for 12 consecutive months. The facility operated 2 10-hour shifts with skeleton third-shift crews performing maintenance. On the production floor, the rhythmic sounds of riveting, welding, and heavy machinery never ceased. 1 tank every 30 minutes,
2 tanks per hour, 48 tanks per day when running at peak efficiency. German tank production, by comparison, struggled with much smaller numbers. Germany's largest tank facility, Henschel's Kassel plant, produced approximately 104 Tiger tanks in its best month. The Tiger was admittedly more complex, but the production disparity revealed industrial capacity gaps that no amount of engineering sophistication could overcome.
Detroit Arsenal was just the beginning. By late 1942, 11 factories across America were producing Sherman tanks using assembly line techniques. Chrysler Defense Arsenal Detroit, 7,499 M4A4 tanks, the largest single-variant production run. Fisher Body Grand Blanc Tank Arsenal, Michigan, 8,147 Sherman tanks of various models operated by Fisher Body Division of General Motors. The facility broke ground in November 1941 and produced its first M4A2 in January 1942 before construction was complete. Pressed Steel Car Company, Joliet, Illinois, 8,147 Shermans, making them one of the big three producers alongside Chrysler and Fisher. Ford Motor Company, 1,690 M4A3 tanks plus thousands of GAA V8 engines shipped to other manufacturers. Ford also produced 1,038 M10 tank destroyers. Pacific Car and Foundry Company, Seattle, 926 M4A1 cast hull tanks, the only West Coast tank producer. American Locomotive Company, Schenectady, New York, multiple Sherman variants through 1943. Baldwin Locomotive Works, Philadelphia, M4 and M4A2 production through 1944. Federal Machine and Welder, Warren, Ohio, 540 M4A2 tanks, producing approximately 50 monthly, the smallest and slowest producer. Lima Locomotive Works, Lima, Ohio, produced the first Sherman prototype in February 1942 and continued production through 1943. Pullman Standard Car Manufacturing Company, Chicago, multiple Sherman variants through 1943. Montreal Locomotive Works, Canada, Canadian production for British and Commonwealth forces. These 11 factories didn't compete, they collaborated. Engineering improvements developed at one facility would be shared across all manufacturers. Component suppliers provided standardized parts to multiple assembly plants. The system functioned as a distributed network optimized for maximum output. Total Sherman production from 1942 through 1945, 49,234 tanks. Average daily production, approximately 45 tanks every single day for 3 years. At peak production in 1943, approximately 60 tanks daily across all facilities. One innovation exemplifies how American industry adapted automobile technology to military equipment: the Ford GAA engine. Shermans initially used various power plants: Wright R975 radial aircraft engines, Continental radial engines, even Chrysler's complex 30-cylinder A57 multi-bank engine, created by combining 5 6-cylinder automotive engines. This variety created logistics nightmares. Different engines required different spare parts, maintenance procedures, and training. Ford engineers designed the GAA specifically for mass production. It was a liquid-cooled aluminum V8 based loosely on Ford's canceled aircraft engine program. The engine displaced 1,100 cubic inches, or 18 liters, and produced 500 horsepower at 2,600 RPM, substantially more power than earlier Sherman engines while being lighter and more compact. More importantly, the GAA used manufacturing techniques and tooling adapted from automotive production. Ford could build these engines on assembly lines similar to those producing civilian car engines. Between 1942 and 1945, Ford manufactured approximately 27,000 GAA engines, not just for Ford's own M4A3 Sherman production, but for other manufacturers' tanks as well. The M4A3 with GAA became the U.S. Army's preferred Sherman variant. It offered the best power-to-weight ratio, excellent reliability, and simplified logistics, since one engine type could serve multiple units. By 1944, most American Sherman production had standardized on the M4A3 configuration. This standardization represented quintessentially American problem-solving. Identify the best solution, produce it in massive quantities, and leverage economies of scale to make quality equipment affordable and abundant. The production statistics reveal disparities that made German defeat inevitable, regardless of tactical outcomes. Sherman production by year. 1942, approximately 10,000 tanks. 1943, approximately 21,000 tanks. 1944, approximately 12,000 tanks. And 1945, approximately 6,000 tanks. Total, 49,234 M4 Sherman tanks. German Panzer production, all types by year. 1942, approximately 6,300 tanks. 1943, approximately 12,100 tanks. 1944, approximately 18,300 tanks. And 1945, approximately 4,000 tanks, partial year. Total, approximately 40,700 tanks of all types. These numbers mask an even larger disparity. German production included light tanks, obsolete models kept in production due to factory tooling constraints, and various specialized vehicles. English production focused primarily on the Sherman medium tank, a single standardized design, with variants differing mainly in engines and minor modifications. Moreover, German production was dispersed across multiple competing designs: Panzer IV, Panther, Tiger I, Tiger II, and various assault guns and tank destroyers. Each design required unique parts, training, and logistics. When a Tiger broke down, only Tiger parts would work. When a Sherman broke down, parts from any 49,000 Shermans were interchangeable. The strategic implication: Germany could produce approximately 1,000 to 1,500 tanks monthly at peak capacity, achieved only in 1944 when Allied strategic bombing was systematically destroying German industry. America produced 2,000 Shermans monthly at peak in 1943, while also producing thousands of light tanks, tank destroyers, half-tracks, artillery pieces, aircraft, and ships. Sherman production was merely a component of industrial output so vast it exceeded the combined war production of Germany, Italy, and Japan. By late 1944, German field commanders reported facing overwhelming materiel superiority. A typical American armored division deployed 230 to 270 tanks. The U.S. Army fielded 16 armored divisions in Europe by early 1945, plus independent tank battalions attached to infantry divisions. The arithmetic was brutal. Even if German tanks achieved favorable kill ratios, which Tiger and Panther tanks often did, American forces could absorb losses and continue attacking while German forces could not replace destroyed equipment. One captured German tank commander, interrogated after the Battle of the Bulge, summarized the situation bitterly. "You Americans fight with machines. We fight with men. Your production gives you endless machines. Our production gives us nothing. We destroy 5 of your tanks and 10 more appear. You destroy one of ours and we have no replacement. How do we win this war?" He couldn't. The industrial disparity made German defeat inevitable.
The Sherman tank's reputation remains controversial among military historians. It was reliable, mechanically sound, and available in overwhelming numbers. But it was also vulnerable to German heavy tanks. Tigers and Panthers could destroy Shermans at ranges where Sherman guns couldn't penetrate enemy armor. The Sherman's 75mm gun, adequate in 1942, became obsolete by 1944 when facing German tanks with thick frontal armor. Upgraded 76mm guns improved penetration, but still left Shermans at disadvantages against heavy panzers. The British 17-pounder gun, mounted on Sherman Firefly variants, offered better anti-armor capability, but even these struggled against Tigers at long range. The Sherman armor, initially adequate, couldn't protect crews from high-velocity German tank guns.
The 88mm gun on Tiger tanks could penetrate Sherman armor from over a mile away. At typical combat ranges of 500 to 1,000 yards, German guns made Swiss cheese of Sherman armor. The Sherman earned dark nicknames reflecting these vulnerabilities. Ronson, after a lighter advertised to, light first time, every time, Tommy Cooker, British slang, and various unprintable terms used by crews who understood they were outgunned and under-armored. American tankers developed tactics to compensate, attack from multiple directions simultaneously, use artillery and air support to suppress enemy tanks, exploit superior mobility to flank German positions. The doctrine accepted that defeating one Tiger might cost 3 to 5 Shermans, but with production running at 60 tanks daily, that exchange rate was sustainable. German production running at 30 tanks daily couldn't sustain any exchange rate. Every Tiger lost was irreplaceable. Every Sherman lost would be replaced by tomorrow's production and forgotten by next week. The Sherman represented American strategic thinking. Good enough was better than perfect if good enough could be produced in overwhelming numbers. The Tiger was arguably the best tank of World War II, but Germany built 1,347 of them, compared to 49,234 Shermans. In total war, quantity has a quality all its own.
The Sherman production miracle required an unprecedented workforce transformation. Before the war, tank production was specialist work, skilled craftsmen in specialized factories building small numbers of complex machines. The assembly line approach changed this entirely. Tank production became factory work that semi-skilled laborers could perform after brief training. Detroit Arsenal employed over 10,000 workers at peak, 60% of them women. Rosie the Riveter wasn't just propaganda. Women operated rivet guns securing armor plates, welded turret seams, installed electrical systems, and performed every job on the production floor except the heaviest lifting. Many had never worked in factories before. They were housewives, students, and office workers drawn by patriotic appeals and wages higher than most pre-war employment. They learned skilled trades in weeks rather than the years traditional apprenticeships required. The work was demanding. 10-hour shifts, 6 days weekly. Noisy, dangerous, exhausting. Industrial accidents were common. Heavy machinery, molten metal, high-voltage welding. But the workforce kept growing because the demand never stopped and the pay was steady. Labor relations proved challenging. Henry Ford, notoriously anti-union, resisted worker organization until strikes threatened war production. The United Auto Workers successfully organized most tank production facilities by 1943, negotiating for better pay, safer working conditions, and overtime compensation. Ford personally opposed hiring women, believing factory work unsuited for them. Labor shortages forced him to relent. Male workers were being drafted by tens of thousands monthly. By 1943, women comprised half the workforce at many tank production facilities. These workers, male and female, understood what their production meant. Tanks rolling off Detroit Arsenal lines would carry American soldiers across European battlefields within months. Every tank assembled correctly might save American lives. Every defect might cost them. The quality control was motivated by more than paychecks. D-Day, June 6, 1944, validated every dollar invested in Sherman production. American and British forces landed approximately 2,000 tanks in Normandy during the first week of fighting. The majority were Shermans. By the end of June, Allied forces had landed over 4,000 tanks and were losing them at rates exceeding 100 weekly to German resistance, battlefield accidents, and mechanical failures. It didn't matter. Production replaced losses within days. Replacement tanks shipped from American factories arrived in France faster than combat could destroy them. By late August, when Allied forces broke out of Normandy, American armored divisions fielded more tanks than they'd started with, despite 6 weeks of intensive combat. German panzer divisions couldn't sustain these loss rates. When a Tiger was destroyed, German units often received no replacement. Panzer divisions that began the Normandy campaign with 100 to 150 tanks ended August with 20 to 30 operational vehicles and no replacements available. German tank production couldn't match combat losses against enemies who could absorb unlimited attrition. The Battle of the Bulge in December 1944 demonstrated this disparity catastrophically for Germany. German forces committed their strategic armor reserve, over 1,000 tanks, including their newest King Tigers and Panthers. They achieved tactical surprise and initial success. Within 2 weeks, American counterattacks destroyed or disabled over 600 German tanks. American losses were higher, over 800 tanks destroyed or damaged. But within a month, American units had replaced all losses and were back to full strength. German losses were permanent. The panzer divisions committed to the Ardennes offensive never recovered. They limped eastward with remnants of their original strength and faced Soviet offensives with equipment they couldn't replace. By April 1945, American armored divisions were rolling across Germany, encountering German units with single-digit tank strengths, attempting to defend against 100-tank American formations. The production disparity had become so overwhelming that individual battles' outcomes were predetermined by the arithmetic of available equipment.
Captured German documents and post-war interrogations reveal how German military leadership came to understand the industrial hopelessness of their situation. General Heinz Guderian, German panzer pioneer and inspector general of armored troops, wrote in his memoirs, "By 1944, the Americans were producing tanks at rates we could not comprehend. Our intelligence consistently underestimated their industrial capacity. When the true numbers became apparent, we understood that defeating American production was impossible. We could win every battle and still lose the war through attrition we could not sustain." Albert Speer, Minister of Armaments and War Production, told interrogators after the war, "We knew by mid-1943 that we could not match American production. Our industrial capacity was perhaps 1/5 of theirs, and Allied bombing reduced it further monthly. I presented Hitler with analyses showing that America could produce 5 times more tanks, 10 times more aircraft, and unlimited ammunition. He rejected these figures as defeatist propaganda, but they were accurate. We were trying to fight industrial warfare against an industrial giant with industrial capacity we could not approach even under optimal conditions." Wehrmacht field reports from 1944 to 45 repeatedly expressed shock at American material abundance. One report from Normandy noted, "Enemy tank forces seem inexhaustible. We destroy 5, 10 appear. Our own replacements arrive as single vehicles after weeks of delay. Enemy replacements arrive by the hundreds within days. This is not warfare as we have known it." German intelligence officers conducting prisoner interrogations discovered that American tank crews were often casual about vehicle losses. If a Sherman was destroyed, crews expected to receive a replacement tank within days, often a newer model with improvements over the destroyed vehicle. German crews understood that losing their Panther or Tiger meant their unit might not receive no replacement at all. This psychological dimension compounded the material one. American tankers fought knowing that equipment losses were temporary inconveniences. German tankers fought knowing that every loss was permanent and irreplaceable.
When Germany surrendered in May 1945, the production statistics told the story of industrial warfare's outcome. Sherman production, 49,234 tanks in 39 months, February 1942 to May 1945. Average, 1,264 tanks monthly, 42 tanks daily, 1.75 tanks per hour. German total tank production, all types, 1939 to 1945, approximately 40,700 tanks over 72 months. Average, 565 tanks monthly, 19 tanks daily. The United States produced more Sherman tanks in 3 years than Germany produced total tanks in 6 years, while simultaneously producing thousands of other armored vehicles, tens of thousands of aircraft, and building the world's largest navy. The cost comparison was equally stark. Sherman M4A3, approximately $44,000, $1944. German Panther, approximately $100,000, equivalent dollars. German Tiger I, approximately $250,000, equivalent dollars. America could build 5 Shermans for the cost of 1 Panther, 10 Shermans for the cost of 1 Tiger. Even accounting for the Sherman's tactical inferiority to German heavy tanks, the production economics made defeat inevitable for Germany. The strategic reality. Industrial warfare, as waged in World War II, reduced to brutal mathematics. The side that could sustain production while absorbing losses would eventually overwhelm the side that couldn't replace destroyed equipment. Germany could design better tanks. German crews often demonstrated superior tactical skill. But superior quality multiplied by insufficient quantity equals defeat when facing adequate quality multiplied by overwhelming quantity. American Sherman production represented this principle in its purest form. Build good enough equipment in such overwhelming numbers that quality advantages become irrelevant through sheer materiel superiority.
The Sherman production program transformed military procurement philosophy for generations. Before World War II, militaries viewed complex equipment like tanks as requiring specialized production in small numbers by skilled craftsmen. The Sherman program proved that military hardware could be mass-produced using industrial techniques developed for civilian goods. This realization influenced post-war military development. The M48 Patton, M60, and M1 Abrams tanks all reflected lessons learned from Sherman production: standardized components, modular design, ease of maintenance, and production methods enabling manufacturing at scale. Soviet tank production also adopted assembly line techniques. The T-34, the only tank produced in greater numbers than the Sherman, used similar mass production philosophy: adequate quality, overwhelming quantity, rapid production replacing combat losses. Modern military procurement still balances the Sherman's lessons against competing demands. The F-35 fighter program, producing over 3,000 aircraft across multiple nations, reflects Sherman-style thinking: standardized platform with variants, economies of scale through mass production, industrial capacity to sustain attrition. Critics argue modern warfare requires smaller numbers of highly capable systems rather than large numbers of adequate systems. But the Sherman's legacy persists. In total war, the side that can sustain production and absorb losses maintains operational initiative that technological superiority alone cannot overcome.
When German intelligence officers calculated American tank production at 150 monthly in 1943, they weren't stupid or incompetent. They were applying logical, analytical methods to available evidence. What they couldn't comprehend, what seemed impossible to accept even when evidence accumulated, was that American industry operated under completely different constraints than German industry. German tank production was limited by specialized facilities requiring skilled workers, competing resource demands from other military programs,
Allied strategic bombing, destroying factories. Raw material shortages, constraining output. Complex designs requiring extensive hand-fitting. American tank production was limited only by how many factories could be converted or built, how many workers could be trained, how much raw material existed, effectively unlimited. The fundamental difference: Germany was fighting total war with industrial capacity designed for peacetime production with wartime modifications. America transformed its entire industrial base into a war machine optimized for maximum output. German generals counting 5 Shermans destroyed daily were performing accurate tactical accounting, but they were making strategic errors by assuming American production operated under constraints similar to German production. By the time German leadership understood American industrial capacity, probably sometime in late 1943, the outcome was already determined. Production gaps that large couldn't be closed through superior tactics, better training, or technological innovation. The industrial dice had been cast, and Germany had lost before the first Sherman rolled into combat.
Popular memory of World War II emphasizes D-Day landings, fighter pilot aces, submarine warfare, and infantry heroism. These stories deserve their prominence. Brave individuals risked and sacrificed everything. But the unglamorous truth is that World War II was won as much on factory floors in Detroit, Grand Blanc, and Joliet as on battlefields in Normandy, the Ardennes, and the Rhine. The Sherman tank program, 49,000 tanks in 39 months, represented American industrial might translated into military power. German generals who counted 5 Shermans destroyed daily were performing accurate tactical accounting while missing the strategic reality. America was building 60 Shermans daily, every day for 3 consecutive years. That production gap determined the war's outcome more decisively than any battle, any tactical innovation, or any technological advancement either side deployed. The workers who built those tanks, many of them women who'd never worked factories before, were as essential to victory as the soldiers who crewed them. The engineers who adapted assembly line techniques from car production to tank manufacturing demonstrated innovation as significant as any weapons development. The Sherman wasn't the best tank of World War II, but it was good enough, available in overwhelming numbers, and backed by industrial capacity that made defeat impossible for any nation attempting to compete militarily with America's productive might. German generals stopped counting destroyed Shermans sometime in 1944. The numbers had become meaningless. No matter how many they destroyed, more appeared. Always more. The arithmetic of production had become the arithmetic of defeat. And no amount of tactical brilliance could solve that equation. The Sherman tank won World War II not through superior firepower or impenetrable armor, but through the simplest, most devastating weapon in industrial warfare: unlimited availability. 45 tanks every day for 3 years from assembly lines that never stopped. That was how America won.
In memory of the workers who built the tanks, the crews who fought in them, and all who contributed to the industrial miracle that helped end history's most destructive war,